Everyone, this is an audio walkthrough explaining my MATLAB designer project that I use for my electrical 3302 signals and systems course, where I'm taking a digital guitar tuner and processing the input signal using concepts learned from class, such as FFT, taking that single-sided spectrum magnitude and then comparing it against the actual pitch of a string in order for it to work as a guitar tuner. So what this app does, I have my left panel set as user inputs, where you can start the tuner and search a range between each string. So for example, this 6-string E2 will be anywhere from 70 to 90 hertz is that pitch range I want to search in. And from there, I'll take a peak magnitude from my FFT of that input signal, get the magnitude in the frequency spectrum, and then compare that against the actual pitch, which is set at 82.41 hertz. Then I will take the error in cents, plus or minus 10 cents, and it'll tell you if it's in tune or not, along with this gauge here below that's set for a specific range. So here's some of the code. This right here is taking the audio input. First, I'm taking the frequency sampling is set at 8,000 hertz or 8 kilohertz as the sampling rate that I want to take my input at. And then this is going to be stored in a vector. So it's 16 bits of data. I'm only using one recording channel. I'll have one microphone for my PC, and I'm going to capture that recording for 5 seconds. Here below, I'm using buttons to narrow the search range that I'm going to put that peak frequency in. So like I was saying before, E2 is 70 to 90 hertz. I want to search that specific range in order to find the highest order of magnitude in that range and compare it against that string. So when this is compared, it should compare it against 82.41 hertz for E2. And then that error in cents calculation that I used right here, we'll then take that and measure that pitch that I took from the input, FFT magnitude, divided by the actual pitch of the string to give you that error in cents. So this is basically what I'm doing in the code itself, taking that recorded signal, computing the FFT, converting its frequency to get the single-sided magnitude spectrum, computing the largest peak, and then comparing it, getting the error. So this is what I'm using to record the actual piece itself. I just use a variable fs to take that recording, and then I'm going to store that in my in, which is my vector I'm storing my recording in. So these are sampling bits from my input signal. And then here I'm going to plot my input signal in the time domain, after which I already computed my FFT in this portion here. And then I'm going to plot that magnitude. Get the FFT, get the single-sided magnitude spectrum, plot it, see where you're at. Here's where I'm searching each band range. So I'm masking the signals in that band range width. I'm creating a width of hertz that I want to search with them from a low frequency set to a high frequency set. And in standard guitar tuning, I only need to go from really 70 up to around 340 hertz. But I'm setting this lower to 50 to 350 in case your guitar strings are off by that much. So this is the range I'm going to set itself in as a generalized concept. And then after that, it's going to be broken down to 1 to 6 strings from E2, A2, D3, G3, B3, and E4, each having a low frequency and a high frequency set at where you can search that bandwidth. Here's the calculations. After that masking, after you set that range, this is going to look for the peak magnitude in each band, right? So I'm taking the peak index of that bin from that bandwidth. And then once you find that peak frequency that you have that guitar string, whenever you pluck it, that peak bin is going to be then compared to that string. Which will then be put into a cents calculation to find the error in that string. And this is pretty much a copy of this in order to find that set range when you press every button. So the user has the ability press a button instead of doing it automatically, saying that I'm going to hit the 6th string E2 and I want to search that range for the string itself, which are called back into these functions. So E2 button's pushed. I'm going to narrow it between these values. So when you start the tuner, you press start tuner, it's going to take that audio recording, that 5 seconds, process that recording onto a plot, after which it's going to take the FFT and the magnitude, plot that onto another plot called tuning, and then that's going to show up in your gauge of where you're at. Red being too low or too high, yellow being a little bit off, and then green being a good range of tuning. After which the end tuner is going to reset all these user interfaces that you're using, the axes, the gauge, and the button press. So we'll go back to the design view, we'll run this code. And you see that the tuner pops up. So the first thing I'm going to do is start tuner, hit E2, start. And after 5 seconds of listening to my input, you can see that it's going to plot it in the time domain as the amplitude of this input audio frequency that I took in from my computer's microphone. Then I'm going to plot it onto a magnitude spectrum after doing the FFT. And this is going to tell you the comparison against that actual pitch that should be. So E2, the 6th string is set at 82.41 hertz. My measured frequency was 82 hertz. This is off by negative 8.6 cents, meaning that it's in tune within my range of negative 10 to positive 10 cents. So if I do another string, but I set this one off from standard guitar tuning. So if I try this again, so you can see this one's off, my second 5th string A2. It's supposed to be at 110 hertz. Measured frequency is 107.6 hertz. This is off by negative 38.2 cents, meaning that it's flat or too low. So if I retune this, pull it up a little bit, and restart this tuner, after 5 seconds, we'll try it again. It's still too low. And there we go. It's back in tune. So this will work with every string. It's going to have a set range to look in. It'll take that magnitude spectrum and again compare it, get the error, tell you if it's in tune or not. And our gauge below will tell you if it's in a good range. And that's it. In tuner, you can see we'll reset everything as well.